Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to be talking about GCF factoring, which is a specific type of factoring that you see all the time in algebra. So first, I want to tell you what GCF stands for. GCF stands for the greatest common factor. And maybe you forget what this is, but don't worry, I'm going to be reminding us in about a minute. And just as a reminder, normal factoring is problems that look like this. X squared plus 2x minus 8. I ask myself, what are the factors of 8? You got 1 and 8 and 2 and 4. Since it's minus, I know it needs to be subtracted, so then it's x plus 4 and x minus 2, because 4 minus 2 gets me the positive 2 in the middle, and there's my factoring. This is normal factoring. But now with GCF factoring, the problem's going to look like this. X squared plus 2x, and there's no minus 8. As a matter of fact, there's no numbers at all at the end, which is very weird because we're not used to seeing this. So whenever you're missing the constant term at the end, this is how you know you'll probably need GCF factoring. And how we do it is pretty easy. All you got to do is ask yourself, what's the biggest term that these two things have in common? This is a simple one. The only thing they have in common is an x. And so I'm going to pull that x out in front and then write a set of parentheses here that I'm going to fill in a second. And then to find out what goes in the parentheses, I just have to divide both of these things by x. X squared divided by x is just going to be x. Not sure if you knew that or not, but that's what it is. And then 2x divided by x, that's just going to be plus 2. So then this is my answer for the factorization. We're done. And sometimes it asks for the solutions. In other words, it would look something like this. X times x plus 2 equals 0. If I want to solve both of these, then the answer is just x equals 0 and x equals negative 2. And the reason why is because whenever you want to find solutions, you set both factors equal to 0. In other words, x equals 0 for the first one and x plus 2 equals 0 for the second one, eventually solving to x equals negative 2. So now we're just going to do a bunch of examples with GCF factoring. I'm not going to ask you for the solutions. We're just going to be GCF factoring alone. So the first one I have here is x squared minus 5x. So what am I going to do for this one? Well, what do they both have in common? They both have x in common. So I'm going to pull the x out in front, divide both of these by x, and that would leave me with x minus 5. And there we go. That's it. These first two are easy examples, but now with the next couple, I'm going to tell you there's more than one thing we can pull out in front. So the next one I have is 4x squared minus 12x. What is the biggest thing these two have in common? The answer is they both have a 4x in common. And if I divide both of these things by 4x, the first one, everything cancels except an x. And 12x divided by 4x is going to be minus 3. No x because the x's cancel. So then this is the solution here. And if you miss the 4, pulling out the 4, I don't want to say that you're completely wrong, but this is the best answer. 4x times x minus 3. Now the next one's going to be tricky, so I'm going to help you with this next one. It's x cubed plus x to the 5th. And yes, we can factor this. So what I'm going to say for this one is the biggest thing that both these terms have in common is an x cubed, because they both have at least an x cubed. So I have to divide both of these by x cubed. Now for the first one, x cubed cancels entirely, which means you're not left with 0, you're left with 1. Very different. You'll never be left with 0 in these problems. And then plus, when I divide the x to the 5th divided by x cubed, 3 of the x's cancel, leaving me now with just x squared. So then plus x squared. And this is the factorization for that one. If that didn't make sense for you, don't worry, we have another one right now. 2x to the 4th minus 32x squared. So for this one, what's the biggest thing they have in common? It's going to be 2x squared times the quantity. Well, if I divide both these things by 2x squared. For the first one, the 2's cancel, and the x squareds cancel, leaving me with just an x squared in the numerator. So that's x squared. And then for the denominator, 32 divided by 2 is 16 in the numerator. And then the x squareds just perfectly cancel out. So then all I'm left with is minus 16. And if you stop here, that's okay, but I can actually factor this further. This is a difference of 2 squares. If you forget what that is, I talk about this in a different video. But basically, x squared minus 16 further factors to x plus 4 times x minus 4. And so then the final answer is 2x squared times x plus 4 times x minus 4. And so that one could have been factored twice. And you may be wondering, could the last one be factored twice? And the answer is no, because it's the plus sign here. If this was 1 minus x squared, just hypothetically, this would factor to 1 plus x times 1 minus x. So now you know. And then I've got one more today. It's 15x to the 7th plus 25x to the 4th. Go ahead, give this one a try on your own now. And as a hint, this one can only be factored once. Do not factor it twice like we did the last one. So go ahead, give it a try. And here's the solution. The biggest thing I can pull out in front is a 5x to the 4th. Because 15 and 25 are both divisible by 5, and x to the 7th and x to the 4th, the biggest thing they have in common is x to the 4th. So then I have to divide both of these by 5x to the 4th. For the first one, 15 over 5 is going to be 3, and x to the 4th divided by x to the 7th is going to be x cubed. So for the first term, you're just left with 3x cubed, and then for the second one, 25 divided by 5 is a 5 in the numerator, and the x to the 4ths perfectly cancel out, so you're just left with plus 5. And this is the solution for this one. This could not be factored more, even if you wanted to. And so that's all the questions I have today. Thank you all for watching. If you have any more questions, please post them in the comments section. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.